Hello SGD, Sacred Geometry Decoded. This series actually throughout my whole channel is based on ancient architecture, ancient metrology, especially connected to the quadrivium and Hermetic knowledge, astronomy, geometry, arithmetic and music, especially through weights and measures. Also how the esoteric world or the occult knowledge, occult sciences, Hermetic knowledge, such as that embedded in Freemasonic traditions and Rosicrucians and the early Theosophists who were themselves either geometricians, metrologists, astronomers and so forth, blends together in a very wonderful way, and it's in a way that instead of on mystery of a big question mark, well, there are some very lovely answers in regards to this. By no means the complete story, however, through the geometry of the Great Pyramids, through the geometry of ancient structures, including the Parthenon or the stone circles in the UK, Ireland, Scotland, etc., how they all blend together in a wonderful way which still defines modern architecture. So the great capital cities, whether it's Brasilia, Washington, Canberra, Astana, London, New York or Paris, how the key points of architecture throughout those embed this same ancient codex of knowledge. Hermes, god of weights and measures. Thoth and Shesset, god of weights, measures, geometry, astronomy, architecture and so forth. And so whether to weigh something or to measure something for its length, well, this will actually link to pendulums and measuring time. And time of the sciences is still pretty much one of the most esoteric, one of the most what's difficult, ethereal in a sense. And this is an important feature because the ethereal leads to the material, to the measurable, which will link to the ancient architecture and traditions across the world. If we begin with this pendulum, it is 1 modern meter long. I've just used the same graphic, so as you can see, but we'll be keeping 1 second depending on your position along the earth. But first, to focus on the pendulum of exactly 1 modern meter in length. Because all of these pendulums need to be swung less than 30 degrees, we'll be using 30 degrees or pi over 6 radian is another way of measuring it. Therefore, a 1 meter pendulum, that 30 degrees of arc equals, by definition, pi over 6 meters or 0.523599. So now we have a meter at this 30 degree arc, creating a very, very effective 1 meter pendulum. However, all of these will individually contain important information. They will blend to one another to contain some very important information. And the first aspect of it is that a 1 meter pendulum at this 30 degrees, the arc of pi over 6 meters is equal to 1 Egyptian Royal Cubit, Old Kingdom Egyptian Royal Cubit, not to be confused with the later ones. There are many surviving cubit rods, and also by applying that to the architecture itself, so many examples of the cubit, not just throughout the Great Pyramid but throughout all of the pyramids. You'll find it in Nilometers, you'll find it in other very important, very old temples of Egypt. And so this concept of 1 meter equals 1 Egyptian Royal Cubit equals 1 second. Measurements of time leading us to measurements of distance or vice versa. So the Egyptian Royal Cubit of pi over 6 meters and the Great Pyramid. Again, this Royal Cubit is not isolated to the Great Pyramid. It is a defining feature of the main Giza pyramids, but we'll also see it in the Red Pyramid, the Bent Pyramid, and again other temples. Schwaller de Lubitz would be a interesting source in regards to this. He was one of the first to really bring forward the connection between the meter and the cubit. But now if we consider it in regards to time, well, measurement, so hertz, which is so important. Well, hertz is measured per second, and if we see the wavelength in meters, so 1 meter, 1 hertz is 299,792,458 hertz. If you're not familiar with that number, that's the speed of light number as well. So we have a very interesting connection between the second, the meter, and hertz, and how these application measurements of time, measurements of distance come together to give us very important tools, SI measurements, international standards. So we go, what is the modern meter? Well, the modern meter since the 70s has been defined by the speed of light per second. So we have a connection again to the meter, to a constant, and this is all about universal constants, geometric mathematical constants, which are being constant. They're universal truths in that sense. And so the meter and the second coming together to give us very, very important integral foundation stones of the science that we have now, and also pointing to these methods, these systems which go back in time. So just to focus on that 1 meter gives us 1 arc of the Egyptian Royal Cubit. Well, now the pendulum furthest to the right, and we'll explore this later, but the straight line between those pendulums now gives us an Egyptian Royal Cubit in a straight line. So we've turned a curve into making of a ruler. If you look at the survey data, for instance, the J.H. Cole survey of a pyramid, if you look at the base length, what we have is based on the average of the base length across the pyramid, it is ever so close to pi over 6 meters. It is 40 microns. It's the thinnest human hair difference. Another interesting feature in regards to the meter and the cubit is that if you add an Egyptian Royal Cubit to a meter, you get 4.99868 ... English feet. Again, such a small difference, where 1.52359 etc. is a meter plus a cubit. 1.524 meters equals 5 feet. Once more, we're splitting hairs in regards to the difference between these, and even over recent times the definition of them has changed ever so slightly, so to nail that down is very difficult, but 0.4 of a millimeter is the difference between 5 feet and a meter plus an Egyptian Royal Cubit, and the relationship between foot, meter and cubit, imperial Egyptian and the modern metric, but also how it all blend to other scales. Now, for instance, pi over 6 meters is 1.178 ... feet. This is a very interesting number in, well, many aspects, because essentially what it is equal to is E minus 1, or Euler's number minus 1. This again is a very important constant throughout so many aspects in chemistry, biology, banking, and as a natural rate of growth. So the difference there you can see between pi over 6 meters, and there in the blue beneath it we see the absolute value of E minus 1, which will bring us to this equation here, Euler's identity, which is said to be one of the most beautiful, if not the most beautiful equation in maths. This particular knowledge, which will lead us back to the pyramids, to the pendulum, to the meter, to the cubit, and the second joins up, because the difference between pi over 6 meters to feet and E minus 1 is a difference of 0.1335 millimeters. Again, such a small margin of error, which goes beyond the margins of error in surveying places such as almost anywhere on Earth, even a modern building, to get it to a fraction of a millimeter. Well, now here you see some examples of Euler's number, why it's so important. So biology, growth rates and interest, radioactive decay, temperature, electronics, probability theory. Well, this will also relate to the golden section of a golden ratio, or phi as it's called, 1.618033, well, etc. This again is another very important number which we see in appearing in nature in so many different ways, from the micro to the macro. So back to the 1 meter pendulum gives us 1 Egyptian Royal Cubit. So we times the base of the pyramid times 440, we have an Egyptian Royal Cubit. The base of the pyramid, we times that number by 280, we get the height of the pyramid. but also in regards to the ratio built into the pyramid. It doesn't matter what unit you use, but the slope to the half base will give you a very, very close approximate of the golden number. However, because the pyramid is not exactly perfectly square, there are slight variations, and these variations themselves incorporate some beautiful knowledge. But to begin with, we have the golden ratio in the Great Pyramid. Again, as I mentioned, each side has a slight variation. There's also the 8-sided pyramid, which gives you an indent, which changes the slope angle, for instance. However, if you incorporate these slight variations, including the indentation and the slight variation on each side, on the left we see the idealized measures of a pyramid, giving us the golden number to 99.96536%. If you include the variations and the actual measures of it, it brings it essentially to 99.9% and above. But we also have E, Euler's number in there, E times 100, built into the idealized. So the base divided by phi, 440 divided by phi, as we already saw, the phi ratio gives us E times 100. So we see a nice connection between the constant of E as well as the golden ratio, and how these blend together, and how one constant leads to another, one system of measurement leads to these constants, and how each of these measurement systems come together. We also, well, one Egyptian Royal Cubit is E minus 1 feet within human hair, but we also have Euler's number built into the proportions of E minus 1, I should say, built into the proportions of the pyramid itself, above 99.9%. Again, if we incorporate all the slight variations, we'll get that to 99.9%, but Euler's identity, E to I pi plus 1 equals 0, one of the most beautiful equations, as they say, in mathematics. This has other important aspects to it, because plus 1 is a feature. So we already saw E minus 1 as a defining feature, as in feet per Egyptian Royal Cubit, and also you see E to the I pi plus 1 coming together. Well, we already spoke about the connection between E and phi. Well, this is one of the beautiful things about phi. Phi squared equals phi plus 1. 1 divided by phi equals phi minus 1. Plus 1, minus 1, these lovely, beautiful equations in which it's defined so much of nature and even our materialist world. So just a close-up of it again. Phi squared equals phi plus 1, 1.618 dot 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 plus 1 equals 2.618033, and or 1 divided by phi is phi minus 1. Beautiful mathematical connections. Now, in previous episodes in this series, I spoke about the sidereal month and the synodic month, and how they're embedded in the pyramid, part of this geometry, astronomy, arithmetic and music. Well, the number of synodic months per year, full moons per year, plus 1 equals the number of sidereal months per year. Another aspect of this lovely connection, Euler's identity, as it's said to be the most beautiful equation in mathematics. And the connections aspects are really in this. I've reviewed some stuff earlier, but we'll be seeing how these other pendulums ultimately connect in a beautiful mathematical proportions. So just to revise, we saw the proportion of the pyramid, where the base divided by the phi ratio gives us E times 100. This aspect of times 10 times 100 times 1000 is another important feature, because we already saw Euler's identity in E. Now we also have the phi ratio, being an important part of Euler's identity. And of course, the pi ratios in the pyramid are one of the most well-known in regards to this aspect, so E times 100. Now if you take the maximum visible base of the pyramid, so 2 bases, divided by the height, you get a very, very good approximate of pi. If you include again the slight variations, it gets even higher than 99.95977%, but just using the idealized for the moment. And it just so happens that the maximum visible base divided by the height, doesn't matter what measurement you use, will give us pi. The maximum visible base in cubits minus the height gives us 600 Egyptian Royal Cubits, or pi times 100 meters. Using the idealized measures, again, slight variations, but again, now we see the aspect of E times 100, pi times 100. How it connects with meters, how it connects with pure ratio, doesn't matter what unit you use. These are repeated themes where every ratio is repeated with mathematics. It's also worth noting that the southern base plus the eastern base of a pyramid equals, well, essentially E minus 1 times 1,000 long inches. And what is a long inch? That's an ancient unit of measure that Michael Parker Pearson has been promoting for some times, and has recently shown in what's called the Folkestone drums, that in the ancient UK, how these drums are a possible way of preserving these measurements simply by wrapping a rope around it. You have a unit of measure, so multiple units of measure, measuring length, connecting to measurements of time, specifically the second, and how these will all connect in together. So it's quite a bit more to come, because each one of these four pendulums has some remarkable maths, some remarkable metrology connecting them to all of the pyramids, all of the great pyramids, not just the Great Pyramid, but also ancient sites across the ancient world, which will embed mathematical constants, as in arithmetic, geometry, astronomy, and music, the quadrivium.